Let's journey back to September 5th, 1977, a day that would mark a turning point in humanity's quest to understand the universe. The world watched with anticipation as engineers and scientists gathered at NASA's Mission Control, their eyes fixed on the future. The air was thick with excitement and hope, as decades of planning and innovation were about to culminate in a single historic moment. On that day, Voyager 1 launched from Cape Canaveral, Florida, riding atop the powerful Titan IIIe rocket. The thunderous roar of engines echoed across the coast, propelling the spacecraft away from Earth and into the vast unknown. It was the beginning of a journey that would take Voyager farther than any human-made object had ever traveled. This mission was part of a rare and remarkable grand tour, a once-in-176 years alignment of the outer planets. By skillfully using the gravity of Jupiter and Saturn, Voyager 1 could slingshot from one giant world to the next, gaining speed and changing course without using extra fuel. This ingenious plan allowed the spacecraft to visit multiple planets in a single mission, opening up new frontiers for exploration. Voyager 1 was more than a machine. It was humanity's eyes and ears, sent to explore the mysterious gas giants and their many moons. Its suite of scientific instruments was designed to capture images, measure magnetic fields, and analyze the atmospheres of these distant worlds. For the first time, we would see close-up views of Jupiter's swirling storms and Saturn's majestic rings. Its instruments would transform distant points of light into dynamic, living worlds, revealing volcanic eruptions on Io, the icy surface of Europa, and the intricate structure of Saturn's rings. The data and images sent back by Voyager 1 would forever rewrite our understanding of the solar system, inspiring generations of scientists and dreamers alike. Today, Voyager 1 is over 15 billion miles from Earth, making it the most distant human-made object in existence. The signals it sends back are incredibly faint, taking more than 22 hours to cross the vast gulf of space and reach our planet. Yet each transmission is a testament to human ingenuity and our relentless curiosity. After completing its planetary tour, Voyager 1 was flung beyond the influence of our sun, crossing the heliopause, the boundary where the solar wind meets the interstellar medium. It became the first spacecraft to enter interstellar space, venturing into a realm where no human creation had ever gone before. Voyager 1 is our first emissary to the stars, a silent scout drifting through the galactic wilderness. Alone in the darkness, it continues its journey, carrying with it a golden record, a message from Earth to any distant intelligence that might one day find it. Every signal it sends is a message from a place no other Earth object has ever been, a whisper from the edge of the solar system. Voyager 1 reminds us that our desire to explore and understand the cosmos knows no bounds, and its journey continues to inspire us all. Bolted to the side of Voyager 1, traveling farther from Earth than any human-made object before it, is the Golden Record, a 12-inch gold-plated copper disc. This shimmering artifact is more than just a piece of hardware. It's humanity's greeting card to the cosmos, a message in a bottle cast into the vast ocean of interstellar space. Conceived by visionary astronomer Carl Sagan and a dedicated team of scientists, artists, and engineers, the Golden Record was created as a message for any future spacefarers who might one day encounter Voyager. It's a carefully crafted introduction, explaining who we are, where we come from, and what our world is like, all in the hope that someone, somewhere, might understand. The record holds a remarkable collection, 115 images depicting life on Earth, the sounds of our planet, from thunder and birdsong to a baby's first cry, greetings spoken in 55 different languages, and a 90-minute selection of music that spans cultures and centuries, from the timeless compositions of Bach to the electrifying rhythms of Chuck Berry. In essence, it's a playlist for the universe, a time capsule of our collective hopes, dreams, and creativity, a glimpse into the very soul of our species preserved for eternity. The cover of the Golden Record is etched with intricate diagrams, showing how to play the record, a map pinpointing our sun's location in the galaxy, and a diagram of the hydrogen atom, chosen as a universal reference point for any intelligent life that might find it. These symbols are our attempt to communicate across the vastness of space and the gulf of time, reaching out to unknown civilizations with the hope of making a connection, no matter how distant or improbable. Even after Voyager's instruments fall silent and its power fades, the Golden Record will continue its silent journey, drifting endlessly among the stars as an ambassador for all humanity, a testament to our curiosity and our desire to be known. It's a cosmic time capsule carrying our story, our music, and our dreams into the unknown, destined to wander the galaxy long after we are gone. For over 4 decades, Voyager 1 maintained a faint but steady conversation with Earth, its data captured by NASA's Deep Space Network. These signals, weaker than a watch battery, provided our only direct measurements of the interstellar environment. Voyager told us about cosmic rays, magnetic fields, and the plasma between stars, vital clues from the frontier. Its longevity is an engineering marvel. Its computers have less memory than a car key fob, yet it survived deep space's harshness. NASA engineers became experts at nursing the aging probe, keeping it alive through ingenuity and dedication. Voyager became more than a tool, it was a partner in discovery, a symbol of persistence. That's why, when its familiar whisper changed to silence, the loss was deeply unsettling. The world held its breath, fearing we'd lost our oldest messenger. In November 2023, Voyager 1's data stream turned to gibberish, a bizarre, repeating pattern of ones and zeros. The spacecraft was powered on, but its telemetry modulation unit was stuck, sending only a heartbeat signal. Engineers at JPL were baffled. The line was open, but the conversation was gone. With no error codes or diagnostics, troubleshooting was agonizingly slow. Each command took nearly 2 days for a round-trip response. Months of attempted reboots yielded nothing. The heartbeat persisted. The team was flying blind, diagnosing a patient 15 billion miles away with only a single cryptic symptom. The mystery deepened, and fear grew that Voyager's historic voice had been silenced for good. Yet, hope remained as the team searched for a solution. The world watched, waiting for a sign of life from the void. The JPL team faced a daunting task: remote brain surgery on a 1970s computer 15 billion miles away. The culprit was the Flight Data Subsystem, FDS, responsible for packaging and transmitting data. Engineers poked the spacecraft with commands, analyzing subtle changes in the heartbeat signal for clues. After weeks, a breakthrough, they commanded the FDS to transmit a full memory readout. Against the odds, a decipherable memory dump arrived. Finally, a clue. Comparing it to old data, they found the problem. About 3% of FDS memory was corrupted, a single failed chip holding crucial code. Without this code, Voyager couldn't package data, resulting in gibberish. The disease was diagnosed, now they needed a cure. The next step would test the limits of ingenuity. The failed chip was irreplaceable, and the lost code had nowhere to go in one piece. The Voyager team devised a daring plan: split the code into fragments and tuck them into free memory spaces across the FDS. Like scattering sentences from a lost chapter throughout a book, they had to ensure every piece could be found and used. Every reference in the software had to be updated. One mistake could end the mission. Weeks of testing and simulation led to a carefully crafted software patch. On April 18, 2024, they beamed the first fragment to Voyager, then waited 45 hours for a response. It was a high-stakes gamble, a digital surgery born of desperation and brilliance. The fate of Voyager 1 hung in the balance. On April 20, 2024, the Deep Space Network received a clean, coherent stream of data from Voyager 1. For the first time in 5 months, the spacecraft reported its health and status. Relief and celebration swept through JPL. Their audacious fix had worked. Over the next weeks, they restored the rest of the fragmented code and carefully powered up the science instruments. By mid-May, 2 instruments were back online. By June 13th, all 4 were returning science data. The familiar whisper from the void had returned, a triumph of persistence and ingenuity. Voyager 1's recovery stands as one of the greatest troubleshooting feats in space exploration. The voice we thought lost was speaking to us once again. Voyager 1 is talking again, but the cause of the failure remains a mystery. Was it old age, or did a cosmic ray strike the chip, scrambling its memory? The cosmic ray theory is likely. Voyager travels through intense radiation far from the sun's protection. This episode highlights the hazards of interstellar travel and the need for robust, self-healing spacecraft. The fix taught us the value of deep system knowledge and meticulous documentation. Future probes may need adaptable software, able to diagnose and repair themselves. The Voyager 1 fix was a manual version of this. Future explorers might do it autonomously. The lessons learned will shape the next generation of interstellar missions. With its voice restored, Voyager 1 continues its lonely journey, venturing ever deeper into the vast unknown. It travels through a realm where no human-made object has ever gone before, likely destined to outlast humanity itself. As it drifts farther from the warmth of our sun, Voyager 1 becomes a symbol of our enduring curiosity and the human spirit's relentless quest to explore. Its power source is fading. By 2036, its instruments will fall silent, ending its conversation with Earth. The faint signals that have traveled billions of miles will cease, and Voyager will become a silent traveler, no longer able to send back its precious data. This moment will mark the end of an era in space exploration, as one of humanity's greatest achievements quietly slips into the cosmic night. Yet, Voyager will drift through the galaxy for millennia, a silent ambassador carrying the golden record, a message from Earth to any who might find it. This golden disk, etched with sounds and images from our world, is a time capsule of humanity's hopes, dreams, and culture, destined to wander the stars long after we are gone. In 40,000 years it will pass near another star, but its true destiny is endless wandering among the stars. Voyager's journey is not just about where it will go, but what it represents, a testament to our desire to reach out, to connect, and to leave a mark on the universe. Voyager's legacy is immeasurable. It transformed our view of the solar system and pioneered interstellar exploration. Its discoveries of new moons, active volcanoes, and the dynamic atmospheres of distant planets have rewritten textbooks and inspired generations of scientists and dreamers. The recent crisis and recovery added a dramatic chapter to its saga, reminding us that exploration is about overcoming challenges. The dedication and ingenuity of the teams on Earth working tirelessly to restore contact highlight the resilience and creativity that define space exploration. Voyager's story is one of curiosity, ingenuity, and persistence. It is a story of people who dared to dream beyond the horizon, who worked through the night to solve problems, and who never gave up on reaching the unknown. Future missions will build on its lessons, becoming more robust and autonomous. The knowledge gained from Voyager's triumphs and setbacks will guide the next generation of explorers as they design spacecraft to travel even farther, for even longer, into the mysteries of deep space. Voyager 1 showed us we can reach beyond our solar system, and inspired us to keep exploring. Its journey is far from over, and as it sails into the unknown, it carries with it the hopes of all who look up at the night sky and wonder what lies beyond.